Hello everybody. Today we're going to be going over the chain rule. And if you've seen my last video, I went over the power rule. So if you haven't watched this video yet, I would definitely start with the power rule. The chain rule is very similar to the power rule, except there are certain times when you can't use the power rule. And the whole point of this series that I'm making is for you guys to know when to use what. These are some of the functions that you can't really use the power rule. You're gonna have to use a chain rule. And the chain rule is very similar. It'll make a lot more sense when I start doing some examples. Uh, okay. So the main difference that we see right here is that instead of just being x to the n, there is an actual function inside the parentheses. But there's still an exponent up here. I'll explain more about that. So this is the chain rule versus the power rule that we have up here. So power rule, we bring the n out front and subtract 1. We actually do the same thing for this. Bring out the n out front. Except this time in the inside there's a function instead of just there being an x. Okay, so we bring the n exponent over, subtract 1 from the existing exponent, and then we leave the function that we have in here, but we want to take the derivative of this function and then multiply it to this, and this whole thing will become your derivative. It'll make a lot more sense with practice problems, but the general idea is kind of similar. Bring the n out front, subtract 1, except you just have to take another derivative of the inside. And okay, we'll do some examples. Okay, so the difference between this and, let's say we had like f of x is equal to x squared. So if we had just x squared, we could just go ahead and use the power rule, the first rule that we learned, to make it 2x, right? Because we bring the 2 out front. But for this one, because there's a function inside the parentheses, we have to use the chain rule. So to do the chain rule, we're going to do f prime of x. We have to bring the 2 out front, like we mentioned already. So we're going to do 2, and you actually leave this function that we have in here for now, 2x minus 1, right? And then we still subtract 1 from 2 to get 1. The difference for this though is that you have to multiply with the derivative of this inside function, right? So the derivative of 2x is actually just 2, because if you think about it, there is technically a 1 over here right now. So if you bring the 1 out front to get 2, or 1 times 2, and then we subtract 1 from the x, then the new exponent becomes 0. So this x kind of goes away. So the derivative of this inside function is actually just 2, because the constant is 0, right? So times 2. And so we can come here and say f prime of x is equal to, so we can do 2 times 2 to get 4, and then the function that we had, and this is your answer. So the main thing here is that for the difference between this and this is that this one there's a function inside the parentheses, while this one there isn't. It's just x, so it's really easy. You could just do the power rule. And this one, you're gonna have to do the chain rule because the inside is more complex than just x squared. So We'll go to the next example. Hopefully that made sense a little bit. Okay. Alright, so in my last video, I kind of did the thing where I moved this upwards, and that's the same thing I'm going to do here. So I'll rewrite this function first. So f of x is equal to 2x plus 5, and then it will become minus 5, right? Because we moved it from the denominator to the numerator. So this is what we're working with here. So same thing here. This is our exponent, which we're going to end up moving in front of the function. Then we leave the function, and then after that we want to subtract 1 to get, it's going to go from minus 5 to minus 6. And then we want to take the derivative of this inside function and multiply it to the end. So let's do f prime of x. So minus 5 goes out front because that's what it was originally, the exponent. And this function stays, whatever you have in here in the first thing, it just stays. Okay, so then, but obviously the exponent changes to minus 6. And one thing we need to do, like we mentioned, is to multiply the derivative of this. And the derivative of this is just 2 again, because a constant 0, and derivative of 2x is just 2. So we just multiply 2 to the end of this. And if you want to write the answer, let me erase this. You just multiply the minus 5 and the 2, so you get minus 10, and then this, so 2x, 2x plus 5 to the minus 6. And this is the chain rule. So the only difference really is you have to multiply by the derivative of the inside. Everything else is kind of the same as the chain or the power rule. Okay, so last question. This one's a little bit different, but for those that don't know, the derivative of sine is actually cosine. So just need to know that before we start this. So for this, what we need to do is that whenever you take the derivative of trigonometry function, you have to see what's in this parentheses right here. So basically for this, what you need to do is do f prime of x is equal to cosine, right? Cosine, because it's the derivative of sine. And then just like before, we kind of leave what we have in here for now. By the way, this sign right here has a 1, so we're just moving the 1 over, which is not really doing anything. If this was a different value, then you would have to bring it over, but for this example, we're not going to make it that complicated. So after you do this though, you have to multiply by the derivative of this, which is 5x to the 4th. And this derivative can be taken using the power rule that we learned. Bring the 5 out front to get 5x, and then subtract 1 from this to get 4. So you have to do all of this to get the derivative of sine of x to the 5. So this is a chain rule. I hope this video helped, and yeah.